Good morning, everyone. My name's Ian Taylor, and I'm just going to give you a brief overview of what we have been doing for the last 2 weeks. We are involved with the sizing company edge-based CV project. This is project number 34. We're currently in our sprint number 1, and during these last 2 weeks we've been implementing minimum viable products from the first 4 modules, which are our distance estimation, pose estimation, brightness correction, and multiple people detection. Each one of these is a deliverable that we are planning to produce, and over this sprint we have just been coming up with investigating different ways of handling each of these options. And just to give you a run through of some of them here, for instance, we've got our user story number 62, and this is, as a business, I want a Python module that checks if multiple people are given in an image, an AI model approach. So the investigation ended up let me just find the page. So during the investigation, we found that there were 2 approaches that could be done, and one of them was using HOG and SVM to detect object or person in the image. And we've just gone through a couple of ways of how to check it. They did find a few problems with this area, and as it was detecting multiple people, I'll just run through some of the code here that they had. So you can see here, this is the code that they came up with, and after running through it, there was multiple objects detected. So then on this NMS Python script, this was trying to handle it, and unfortunately it wasn't. There was still a bit of issues with that, so we've decided to go with approach number 2, which is using an open pose to detect the person from key points that were detected, and it'll return a JSON key point set. So this is still a work in progress, and as we look at the chart here, most of the deliverables here were finished, and it's now just actually investigating further on the open source area. While I'm on this chart, I'll just give you a view of our burn down chart, and as we can see, we had a couple of slow starts in the middle area, but we seem to be on track, and our sprint is looking good. I'm just going to pause the video while I move on to the next deliverable. Continuing with our video here, we're just moving on, and I'll now move on to our user story number 60, which was, as a business model, I want a Python model that checks the pose position of the user image. And as we can see here, these were all the tasks that were carried out. We chose a pre-trained pose estimation implementation and downloaded the repository. We created a function to turn open pose key points into body part dictionary, and clean open pose directory to lower the overhead. Created a function to label key points and get open pose Python modules to run in the development environment. Just switch over here towards the README here, and the goal of this module was to ensuring that the whole body is within the frame and at a suitable distance for the data to be collected. This means that none of the limbs can be cut off, and the user's body can't be too small in the frame. Additionally, we have to watch for issues of the body being a certain distance from the frame edge and look at a minimum acceptable distance for these edges. Possible method 1, we can use a pose estimation model to check the landmarks of key body parts. These landmarks can then be used to check various conditions. And this is still part of an ongoing process of getting the system to work, and for this reason I won't be running the code, but as we can see here, we have come up with a way of using OpenPose and to test some images. And this user story is coming along nicely, and as I said before, it is a bit of a working progress, and we still have a bit of time on our burn down chart to carry on investigating it, and we'll be continuing working on this area. Continuing with our video here, we have the user story number 61, and this was to do with creating a Python module that checks the distance of the pose figure. This also aligned with our previous user story, which was the pose position of the user model, and these were both actually combined into a lot of investigation and getting to use open source on these images to be able to figure out how to handle this situation. Just continuing with our artifact review, we had another user story was to check an image's brightness and the contrast, and to do this we decided to try create a module that wasn't using AI for this, just to see how it goes, and we ended up creating using CV2 mainly. And here's an example, and as you can see, we can run through the image. We have picked up the brightest spot on the image here, and you can see with a circle marked around the picture. And we've also checked that pixel to make sure that there's a certain area around that it's not just one bright spot, but actually a bright area. And this has worked well, and is able to check all the bright images that we've got. We also went through and checked the contrast of images, and we used two methods here. And basically it runs through, uses OpenCV, creates a grayscale picture of it, getting it down to one array, and we carry out a blur effect on it, and we can just check the threshold of, we use is low contrast, which is a SKI image exposure method, built-in function, and that actually just tells us whether the contrast is decent on the image or not. And the second method was to actually carry out a statistics means on the different contrasts, and this also works well. So once we get more samples of images, we'll be able to run through this and actually check. And just combining both these functions, and we will have a nice deliverable to begin with, to work with, a prototype for this deliverable where we can actually run this Python code and detect the images. So far our team is doing well. We're happy with our progress. We've still got some areas to continue working on, but our 4 deliverables have a good start, and we're going to continue moving forward. Thank you for listening and watching.